Hi guys, welcome to today's class, still on physics and on motion. We have here today a problem to solve, an interesting one too. It says that an optimal brand of saloon car traveling at 72 km/h is suddenly brought to rest after 4 seconds. Question is, compute its retardation in meter per second and the distance traveled during the stopping process. I always tell students, especially in solving physics, the first thing you should always do is to check for the parameters that are given. Once you have them, then it becomes easy to solve because physics is a problem of use a formula to solving physics. Now, have here given, we have initial velocity u to be 72 kilometer per hour. We have the time t to be 4 seconds. Acceleration is not given. Final velocity is not given. Distance is not given. Now, it says compute its retardation in meter per second and the distance traveled during the stopping process. Now, remember, the initial velocity u is given in kilometer per hour. We have to first of all convert it to meter per second. Now, we have a solution. We have that 1000 meter is equals to 1 kilometer from our basic science and early secondary school. We have that 1 hour is equals to 33,600 seconds. Now we have to convert this to meter per second. It's in kilometer per hour. We have to convert to meter per second. And they have taught this in mathematics. So people, if you have not really watched it, it's also good that you watch it. Then among the last topic I taught in mathematics. So solving this, we have that 72 kilometer over 1 hour divided by 1 hour over 3,600 seconds multiplied by 1,000 meter equals to 1 kilometer. This is just as good as finished. Now, discover that kilometer will cancel kilometer, hour will cancel hour. We are left with meter per second. If you multiply 72 by 1 by 1,000, you will have 72,000 over 3,600 seconds is meter. This cancel this cancel this. 720 divided by 36, you will have 20 meter per second. Now this has been converted. Now we also have that acceleration is equals to final velocity minus initial velocity over the time taken. And from what is given, final velocity is not given, so I assume it's 0 minus initial velocity, which is now the 20 meter per second over the time taken, which is 4. So I have that 0 minus 20 minus 20 over 4. Therefore, acceleration will be minus 20 over 4 will be 5, and then minus 5. Now we've gotten the acceleration. Now, using the formula S, that's distance, we are asked to compute retardation and the distance traveled during the stopping process. Now this is retardation because minus 5 means that it's slowing, it's reducing. The speed is reducing. Now the distance here S equals to, from the formula I've given, ut, let me write this t properly so I don't confuse people to the plus. Ut plus half 80 square. Now substituting this now, we now have that our u is now 20 multiply the time, which is by time, which is 4 seconds, plus half times the acceleration here, which is now deceleration, is minus 5, and the time taken, which is 4 seconds, 4 square. X equals to 4 by 20, 20 times 4 will be 80, and 4 by 16, if you multiply 4 raised to the power 2 is 16 by 5 and by half, we will have minus 40. Because of this minus sign, minus plus will be minus. Therefore, the distance here will be 80 minus 40 is equals to 40 meter. At simple as that. You can see the process simply arranged, and finally you got the answer. There is nothing difficult here for students to fail. Thanks for watching, and watch out for more problems in motions and physics. Bye.